Hello everybody and welcome to episode 4. The first thing I want to do today is fix the situation where when I load an image, it currently stretches it in both the X and the Y direction to fill up the screen. I'd rather have it maintain the same aspect ratio, so I have an idea of how I could do that, and that is the first thing I'm going to do today. So at the moment, I've almost got it working the way I want to. It wasn't too bad. The only thing odd that's going on now is if I load the image, you can see that it doesn't mess with the aspect ratio, and it's resizing itself. The only thing that's odd about this, or not odd, I mean I understand what's going on, is that if for whatever reason I make the window really small and then I expand it again, the code is currently taking the most recent copy of the picture and resizing based on that. So if I'm down here and it's resizing up, it's taking a very, very low resolution image and just blowing it up. So I bet if I did this a bunch of times, at some point, yeah, it'd just be unreadable. Not that you'd really do that when you're using this necessarily, but it is a bug and I don't want it. I don't want it there. That was pretty easy. Now I can make it really, really small and then bring it back up and it'll be fine. The only thing I did is in this line here, rather than resize the image and overwrite itself, I just take the image, the resized version of it is just new image, and then I run that new image through the photo image class, and it puts it onto the canvas. So effectively what's happening is when the user first loads an image, that is staying in the application's memory. And whenever you resize the window, it's performing, oops, not that one. It's resizing based on the original version of the image rather than the current image that's printed on the screen. And so I'll show you guys how I made this work. Not too difficult. This is effectively all the new code that I've added. What I do is I get the current, the size of the original image that was loaded in, and I compute these two ratios, the width ratio and height ratio. So this is, I take the width of the image and I divide it by the width of the canvas, and that comes up with some number, probably a fraction, something less than 1, because it's unlikely the image is going to be larger than the canvas itself. So pretend that the W ratio is 0.7 and the height ratio comes out to 0.5. I'm limited by whatever my larger ratio is, because if I were to take an image and blow it up, it would hit the edges of the canvas when the larger dimension hits it first. So my scale factor is driven by the maximum of those two ratios, and then to blow up the image, I take my image width and I divide it by the scale factor. So again, the scale factor is probably less than 1, so dividing by a number less than 1 is it's going to multiply it and make it larger. And this was what I just mentioned, in that I take the image, I resize it, and I save it as the new image. And that new image runs through this photo image routine, and then it gets put on the canvas. So it's a pretty easy fix. I think it helps. I will probably be modifying this section of code later on when I introduce some type of zooming feature, because effectively what I'm doing when I'm zooming in and out on the image is resizing it. So I'll probably have to revisit this. Something I just did now is kind of a cleanup, is I realized that when I loaded the image, I was never actually putting the file path here like I wanted to show, which was easy to do. It's just a single line of code. I set the value of this entry as the image file name. I was worried, I wasn't sure if this image file name was going to return the full file path, but it does, so I like that. And the next thing I want to get going is to continue with this calibrate routine. I would like to be able to click on these 4 corners and immediately open up some type of dialog box that lets you put in this case it would be 0, 20, -1, and 2. So I'm going to work on that next. I'm sorry, you guys. I had intended to do this like I did the last video, where I have kind of a time lapse of where I'm coding and what I'm writing down, but I was just way too unfamiliar with what I was trying to do. It was going to be a lot of Googling and not a lot of efficient code writing. But it's a couple hours later, and I think I've finally got it running. It's been an effort. It's been a journey, but what I'll do is load in the sample image, which is here. Make it full screen, and I calibrate the axes, the button's pressed. I click here, and it pops up this little dialog box. I enter -1.5. I hit enter, and then I come over here. X max it's asking me for, which was 20. Oh, I messed up. That's supposed to be 0. Whatever. It doesn't matter. But you can see it added -1.5 up here, 20. I'm just going to make this something 0, and then 2. So it does all that. It doesn't yet put anything on the screen telling you where you clicked. That's to come, but then you can see the calibration button has re-popped up and it's ready to go again. And the cool thing about this is also if I want to do it again and, pretend I put in a point and I'm in the middle of entering this point and I, for some reason, want to destroy the window, I destroy it and then my terminal comes back and it's not hung up anymore, which is really nice. That was getting really annoying earlier. I had to keep, while I was debugging it, I had to keep clearing out of my window and then I was hung up on that wait variable. And so I'm going to talk you guys through what I did and yeah, show you how it's working. Okay, I'll try to explain this in sufficient detail without going for too long. But we are here in the on button press callback, which happens after you press the calibrate button. This is pretty similar to earlier. Button becomes disabled, which is the same as earlier. And then I erase whatever existing calibration data was before. As it turns out, I don't really need this Boolean anymore because I'll get to it in a minute, but I'm no longer doing the method of the TK wait variable. But this Boolean might come in handy later. For instance, if the user tries to grab points before they've calibrated the axes, the code might check to see if this is true or false, so I just left it. And then it opens up a binding on the canvas such that whenever you click on the canvas, it brings you into on mouse click callback, which I renamed. I think before it was called get chord or something like that. But we're here in on mouse click. I append the X and Y coordinates of wherever the user clicked within the canvas. And these are, I was running into this earlier, these are local XY coordinates measured in pixels inside of the canvas. So if you click in the upper left corner of the canvas, you'd get the point 0, 0. Now this on mouse click event, it doesn't know whether you're doing the first calibration point or the second one or the last one. So I have to kind of put in some logic here to help it out. And there are effectively four possible solutions. You're either selecting Xmin, Xmax, Ymin, or Ymax, which I just have in a dictionary here. And the label that ends up populating that pop-up window is just indexing the dictionary by however long your calibration data is. So if this is the first event, your calibration data will be will have a length of 1 by the time you get to this code because you've already added the point up here. So that's what picks the label. This is completely new. This is a new class I made, a new widget. And what it is I'm calling it cal entry, and it's inheriting from TK top level, which is a kind of a general purpose widget that's used to make mostly dialog boxes, as it kind of says right here on the screen. And that's what I'm using it for. I'm using it to make the dialog box that pops up when you click on a spot. And there's some pretty just general geometry that I'm feeding into it. This is, I'll have to play with this a little bit because currently I have it populating relative to my own monitors here. So when it gets later on in the project, I'll have to put some more thought into, people might be running this application and have a different setup of monitors. But effectively, I'm feeding this class the X and Y coordinates of where the mouse was clicked, and then I offset it by a little bit, like -10, -10, just to, my thought was just to get the dialog box out of the way of where the user clicked, because presumably wherever they clicked, it probably says what point they're supposed to be entering in. So I just kind of moved it out of the way a little bit. It's got a label and an entry, which are the label and entries that I already created. So they're kind of the augmented version of the TK base label class. I mentioned way back when in episode 1 that a big thing I wanted to do is have the focus set in the entry box as soon as you click. It's not hard to do. You just do entry.focus set, and then that means that as soon as you click, the cursor will be blinking and ready for you to enter whatever you want to enter. And then I set up a binding event where, you know, the user punches in a number, they punch in 20, and how do you get that dialog box to go away? You hit enter, and the dialog box, we're pushed into the onReturn callback, and the dialog box destroys itself. So it's a pretty useful class, pretty simple class, and that's what's happening here. And I mentioned that I'm no longer using the TK weight variable approach. There's a very similar functionality. You can do TK wait window, and what that does is the application pauses until a window is destroyed. Rather, before it was waiting for a variable to change state, but that obviously I noticed was pretty buggy. This is a lot easier, and if you like abort in the middle of using the GUI and you just, you know, hit X, it'll destroy all the windows. The application will sense that the windows have been destroyed, and it will, you know, like return control back to the operating system, basically. So that is that was kind of getting two birds with one stone, because I was always going to have those little dialog boxes pop up, and I can control the application when it pauses and waits for information by just waiting for those to be destroyed. So that's pretty nice. This is another instance where I have to have some logic, because this callback doesn't know which calibration point it is. So it's checking based on, you know, what was my selected label. If my selected label was YMin, that means the YMin entry field is getting set to whatever the calibration value was. And every time you click the mouse at the very, very end here, it's checking. It's asking, has there been 4 calibration points? And if there has, it means you're done with this routine, and this is when it kind of unwinds. It sets this boolean to true, it tears down the binding, and then it re-enables the button, and then you're back into the graphical main loop. I think the next order of business is to actually put some type of dot or clip art type thing where you click on the axes. So I'm gonna try to get that going now. Okay, I've got it working now. I'll show you guys. I had to make one small change, a couple changes to the on mouse click callback event. One is I also added this possible color for whatever color the dot is going to be. So when you're selecting from the x-axis, it's going to be red. And then likewise on the y-axis, it'll be blue. And all I do is index the dictionary to find whichever color is appropriate given which calibration point you are selecting. And within this code, it's only a single line that I've added. Yeah, only a single line. And I added this make circle method to the canvas, which I will show you. It's pretty simple. So I'm here in my canvas class, and this is what I've added. What it does is technically it adds an oval. That's the method that's available. The TK method available to the canvas class is create oval. All you do is specify an upper left hand point, a bottom right hand point, and I just calculate those on, I feed the function the center point, the XY center point where I want it to be, and then I just do some, I just can compute the corners based on the diameter that I set. I think 10 is a reasonable diameter, 10 pixels, and then I just color it. And so I'll show you guys it working. I'm gonna load in my image, sample, full screen, calibrate. I click here. Oops, I need to get a little better with the placement of this dialog box, I think. 0, you can see I added a little dot, and 20, and negative 1.5, you get the idea. Oops, and 2. So it's working like I want it to. Some initial thoughts I have is that it's kind of a shame that, you know, if you happen to click on top of another dot that you can't see it. I don't believe there's any sort of out-of-the-box way to draw, like in GRABIT, it has kind of a circle with an X through it, so you can kind of see if two points are stacking on top of each other. I might explore some, I don't know, some pixel art, or I guess it would have to be some type of just 2D sprite that I put onto the screen, not sure. So yeah, it's working pretty good. I lied. This is not done yet. And what's messed up with it is if I resize the window, these all get messed up. And then when I resize back, they get lost. So there's not only is there position, there's one over here that's funny. So not only is their position getting kind of, it looks like their position is just staying in the same spot on the monitor screen. There's also a layering thing I need to fix as well to always get them to show on the top level. Alright, you guys, it is a few days later at this point. Trying to get these dots to move where I want them to. turned out to be quite a difficult problem. By the way, if my audio sounds different at all, I went to record and it seemed as though my settings changed, so I tried to get them back to where they were. So that's the reason for sounding possibly different. But I'll show you what I've got going so far. What's working is if I resize the canvas, you can see the dots are moving like I want them to. But notice that when I'm doing this, the image is not actually changing sizes. If I were to move the Y, the vertical distance, that would force the image to change, and you can see the results are not what I would have expected. So I've got to figure that out. Been playing around a lot with image scaling and then shifting the points back, and it's pretty complicated. So I'm going to keep grinding away at this, and hopefully I'll have a solution soon here. That still works. Let's see. Ah! Come on! Oh my goodness. Oh. That didn't work. I think I've finally got it, you guys. Look at this. I've got my dots here. And when I move the window, are you ready for it? Ah! Look at that. Oh, it's beautiful. It's so beautiful. I've probably spent, oh man, it's gotta be certainly several days and probably 5 or 6 hours of continuous just thinking and trying to figure this out. And the final solution was so simple. It's really only 4 lines of code that is doing this. It's a few more, but 4 lines of code is doing the heavy lifting in terms of the math behind this. Oh my goodness. That is very nice. I'm very pleased with that. All right, I'll show you how it works now. So the main thing that has to do with resizing this image is understanding that any point on this image is always going to be, it will always remain at the same relative position. And what I mean by that is, look at this red dot for just a second, and if I were to estimate, I'm just going to say, all right, it's 15% of the way past the image. You know, if halfway would be here, this is, call it 15. And no matter what size the image goes to, that percentage is always going to be the same. That ratio is going to be the same. You know, this dimension divided by this dimension, the width of the image divided by how far it is from this edge or how far it is from this edge. That's the key. And what makes it a little bit tricky though is this width right here isn't easily obtainable. You have to do some math to get to it. So what I did to help understand this is I just drew up a quick sketch. Pretend that this black box around the edge is the canvas, and then this blue rectangle is the image. And these are the dimensions that we have available to us. We can very easily get to the width of the image. We can get to the height of the image, and then the width of the canvas and the height of the canvas. Now the dimensions where TK positions anything within the canvas is represented by this X dimension here. Measured positive X is coming from the left-hand side of the canvas, and then positive Y is a little bit strange. It's measured down from the top of the image. The dimensions we're trying to get to are these dimensions. And the way we can get to those is by taking the width of the canvas subtracting the width of the image, dividing by 2, that will get us to this width right here, the width of this frame, if you want to call it. And then all we do is take x minus that. That gets us to this length right here, and then we divide by the image width, and that is what gets us to this ratio. And the key thing is, all we need to do to reposition this dot is we take the width of the image after it's been resized and back calculate a new XL dimension, and then we can work this expression backwards to come up with what's an X dimension to position the dot after the image has been resized. And that's effectively what the code does. We're back into the code, and that equation that I just had on with the PowerPoint, that's what this is. So I'm saying the distance that x is from the left-hand side is equal to the dimension x minus the difference of the canvas width and the image width divided by 2. That whole quantity divided by the image width. So this is actually, I should probably rename this, but this is actually the ratio, the percentage that that dimension takes up from the entire image. And all we do to calculate x1 is effectively we take this portion of the expression and we set it equal to the same exact version of the expression, but replace all of the zeros with ones, because in my code, 0 represents the dimension prior to resizing, and 1 represents the dimension after resizing. And so if you work the algebra, you effectively get this, which tells you what is my TK X dimension that maintains the same ratio. And as I've showed you before, that's what makes this work, and it resizes it appropriately. It ended up being a pretty simple solution. I spent a long time trying to figure this out, but I'm happy that I have this working. It's very nice to have this behaving the way I want to. And what's even better is that when it comes time to actually put data on the image here, I already have an engine, so to speak, for how to resize these points and reposition them, which is very, very nice. This was something I was not entirely sure how was going to get done, but I'm glad that I've got it figured out. I may clean it up a little bit. I'll have to rename some variables, like I said, but I think this is good. I think with that, I am going to call it an episode. So that would make episode 4. And I think in the next episode, I'll probably work on grabbing the points, I suppose. That's probably the next logical thing. Yeah, so thank you guys for tuning in again, and we'll see you next time. Bye.